All right, so we're going to revisit balancing chemical equations for those of you who are having a little trouble and who may just want to see it modeled for you a little bit longer. Now remember, when we have an equation, we have reactants on one side of the equation. Those are actually going to be in red today. And then you have products. Now in between here, you will have basically an arrow. And that arrow means that one side yields the other side. So what I mean by that is this side, the red reactants here will actually turn into the green products right here. Actually, more like right there. Now, one of the first steps when you're balancing a chemical equation is to be sure that both sides have exactly the same number of atoms of each element. So we begin this very simply by listing out our elements on each side. So if I look at my reactant side, this red side here, I will see that I have a C, which is carbon, I have an H, which is hydrogen, and I have an O, which is oxygen. Now you'll notice that it says over here to the right that if you wait for a little bit to start with oxygen, you'll be in a better place. So if you start with oxygen, you're going to have a bad day. Oxygen just kind of, because of the way it's situated, especially in this equation, it allows you to have some flexibility if you wait to do that until the end. So the next thing we're going to be doing is taking a look at how many of each of these we have in our reactant side. So for carbon, we have one. You'll see that there's only one element of carbon. There is no number after it. Hydrogen then would be 4, and oxygen we would have 2. Now on the other side, what we want to do is double check that and see how much I have from the other side there. And so I'm going to draw a little line here in between because we like to make sure that I'm going to give myself a little more space here. A little more space. Let's go ahead and get rid of that. We want to make sure that in between we have almost like a T. So we like to actually design it a little bit like that. And on the other side, what I'm going to be doing is doing the same thing. So I have a C on this side. Now I want to make sure I line mine up across from one another. So I'm going to put the H next. And then from there, I have the first O, which is with C, and it's O2. And then I have the next O. And I want to do these separately because when I put a coefficient in front of them, I'm not going to be able to affect them in the same way. So I want to make sure that I separate them. Now, as I look at my picture here, I just need a little bit more space. So I'm going to move my arrows around just a little bit and my stuff around so that we can have some space to do some writing. Now, when I look at this side, I have to do the same thing. For C, I have 1. So these guys for right now are balanced. For H, I only have 2. So there isn't a balance there yet. For my first O, I have 2. And which is okay until I find that my second O, I have 1. So for me, I like to kind of give myself a little note out here that I actually have 3 that I have to be concerned about. So my oxygen has 2, and my oxygen on the product side have 3. So I want to be aware of that as I move on. So what I need to be doing here is I want to look at putting coefficients before the elements or before the molecules on each side if they're necessary. And when I put a coefficient in front of them, what that does is it increases the entire molecule. So for example, and I wouldn't start with the O's at all, but let's just say that I put a coefficient in front of this one that was 2. Okay? So now originally, if you look to the side here, the first O2 looks like this. So there's 2 O's that are attached or bonded together. That's what makes it a molecule. By putting a 2 in front of it, now all of a sudden I have 2 of them. So what we're doing when we put a coefficient in front of it is we are actually multiplying the molecule. So this would give me 4 instead. Now I actually don't want to do that. So instead of doing that, I'm going to get rid of my little, I don't want to get rid of the whole thing because that would be kind of a bummer. So let's not do that. Okay, so what I'm going to want to do is make sure that they're balanced on each side. So I see that my C's are balanced, my H's are not, and my O's are not. So I don't want to start with O's. As you see on the side, it says if you start with oxygen, you're going to have a bad time. So we're going to go ahead and start with H's and see how that works for us. So in order to do that, I have to put a coefficient in front of the H2O molecule. So I know that if I multiply this by 1, obviously I have what I had before. But if I multiply it by 2, we'll start small. That would give me 4, and that is actually going to match. So I'll put a 2, which is a coefficient, in front of it. And when I do that, I'm also affecting the O. Okay, so the O, that O that was single by itself now is also being multiplied by 2 because the coefficient applies to everything that's in the molecule. So with that now, I actually don't have the 3 anymore. Now I actually have 4. Okay, so my C's are still matching. My H's are now matching. My O's are off a little bit, but this is why I waited till the end to do the O. So now if I take the O2 and I multiply it to make it 4, I only need to do multiply by 2 to do that, and that will give me 4. So when I put a 2 in front of that, I end up with a balanced equation. Now, we do the equation. We're going to try it again. We have the reactants here. Oh, we don't have reactants. We actually have a bunch of things that I'm just drawing on, which is awful. Let's not do that. New at this, so we're going to go ahead and try to bear with me if you would. All right, so we have reactants, which are U plus F2. I have a nice little arrow here that tells me that I'm going to, this U plus F2 is going to create something. It's going to yield something. And that yield is going to be UF6. Now, just by looking at this one's a little bit more simplistic, but by looking at this one, you should be able to tell that they're not balanced. So I'm going to go ahead and take my steps like I've done in the past. I'm going to list my elements on the reactant side. So I've got a U. I only have one of those. I have an F, and we have 2. Now, again, I like to draw my little line down the middle so that I don't, and make my T-chart so I can keep things organized. On the other side, you'll notice I have a U and there's 1, and I have an F and there's 6. Now, I need to try to make sure that I put coefficients where I need them so that I can balance this equation. Now, my U's are equal already, so I don't have to worry about those at this point, but my F's are not. I've got 6 on one side, I've got 2 on the other, and so in order to do this one, we want to make sure that we try to make them so that they are basically the least common multiple. So I can't make 6 2, obviously, but I can make 2 6. So I do that by multiplying it by something that will create 6 of them. So if I know my math, I can multiply the 2 by 3 to give me 6, and that would mean I'd have to put a 3 in front of this. And now I actually have a balanced equation on this side as well. A little bit harder, and I'm wondering if you can handle the heat of this one, because this one's going to be tricky. Again, I keep drawing on myself, and I just don't know why. Let's not do that anymore. We have the reactants on one side. We have the products on the other. We're going to create an arrow between them. Okay, that way that tells us that our reactants, which are in red, will make our products, which are in blue. And so I'm going to slide these over just a little bit. My arrow's a little bigger than I needed it to be. We have to make sure we can see everything as we do this today. We've got a new level here. We've got our parentheses that kind of change the game for us. So we're going to do the same thing, except that we're going to handle our parentheses just a little differently than we did before. Well, it actually just changes the game altogether. So I'm going to list out my elements on my reactant side and how many I have of each. So I've got Al, and there are 2 of them. My SO4, you'll notice that the SO4 here is also SO4 over here. It doesn't change, it doesn't break apart. So I can list these uniquely together as SO4, as a grouping of SO4. This is what we call a chemical group. I have 3 of those, and I know that because if I look at my if I look at the 3 right here, it tells me I've got 3 groups, because the 3 outside the parentheses applies to everything that's inside the parentheses. Okay, so keeping that in mind. Now, I also have BA and I see that there is no number after it, so I have 1. And again, I'm going to look at my grouping. Now, groupings aren't always in parentheses, but that's usually a clue that they may stay that way if you take a quick peek at them. So I've got them in parentheses here. I have NO3, and I also see NO3 over here. So if I had NO and just NO over here, that would not be what we'd consider a chemical grouping at this point. Okay, so by looking at that, then I know that I have NO3 as a group, so that's nitrogen and oxygen, and I have 2 of those. Now, we've already talked about how we know when a new element is part of a molecule and everything, so we're not going to review that. If that's something you need some help with, let me know. We can certainly go through that together. I'll make my T-chart. So on this side, I've got Al. I only have 1 of them, so I see my first problem. I'm going to line them up next to each other. So NO3 I have down here, and I have 3 of them because I've got the 3 on the outside there. And then I have my Ba, which I'm going to put here right across from its friend, and there's only 1 of them. And then I see my group of SO4, and I only have 1 of those groups of SO4. So I like to deal with the ones that are a little trickier first. So I'm going to start with SO4. I can see right away that they are not balanced. So I'm going to go ahead and I'm going to multiply the SO4 group by 3 because I need to make it 3. And so since I have 1, I want to make it 3. So I'm going to do that. And in order to make that change here, I need to put a 3 in front of this. Now when I put a 3 in front of it, I'm also affecting my Ba. Okay, so it's really important that when you do this that you take it step by step and that you don't rush through things. So one domino knocks down the other. So as I look at Ba here, I know that these guys, my SO4s, are now balanced, but sometimes when I continue to balance things, I have to go back and revisit them. But right now my SO4s are balanced. My Bas are not, so that's going to be my next task. So I'm going to look at my Bas. I need to make them 3. So if I multiply that by 3, then I'm able to go ahead and say that I've got 3 here. And in order to do that, I need to put a coefficient of 3 in front of it. But as you see, my dominoes keep falling. I now need to change my NO3 to, I need to basically have 3 of the NO3s. So right now I only have 2 of them. Now it's making me multiply this times 3 in order to get that. So now I've changed that to 6. Okay, so my Bas are balanced. My NO3s are now not balanced. So if I look at the NO3 over here, how do I make that 6? Well, if I multiply it by 2, it turns into 6. So in order to do that, I need to put a 2 in front of it. And that's actually perfect because if you notice, so now my NO3s are balanced, but my ALs are not. But if I need to make my AL 2 over here, I also need to remember that by putting the 2 in front of the AL NO3, I've also affected my AL, and so now my ALs are balanced as well. So that's just a little brief modeling for you of how to balance chemical equations. We'll be working on this in class, so if you need more help, you'll see me then.